We've all seen it happen. You're in an interesting online discussion, and all of a sudden, it just spirals into this mess of insults and hostility. It's a huge challenge for keeping online spaces healthy and productive. So, I decided to tackle it head on. I set out to build a system that could automatically detect toxic language. In this explainer, I'm going to walk you through exactly how I did it from the very beginning all the way to the final and kind of surprising results. So, what are we really talking about when we say toxic language? It's so much more than just a few curse words. We're talking about communication that has real damaging consequences. I mean, think about targeted harassment and how that impacts someone's mental health, or how it drives social polarization, pushing all of us into these angry little echo chambers. For any online platform, this stuff is a killer. It drives good users away and just ruins the community for everyone. And that's exactly why tackling this is so important. So, here's how we're going to break it all down. First, I'll lay out my 3-model game plan. Then, we'll get into the weeds with the data and the training process, which is absolutely crucial. After that, we'll see which model came out on top, and I'll wrap things up by sharing the biggest lessons I learned along the way. Alright, so let's dive into section 1, the 3-model game plan. My strategy here was pretty simple, really. It was a head-to-head competition. Instead of just betting on one single approach, I decided to pit 3 different deep learning models against each other. I wanted to see which one could most effectively sniff out these toxic comments. Now, here's the fundamental difference between our contenders. On one side, you've got the traditional models, LSTM and GRU. You can think of them like students trying to learn a language completely from scratch, just word by word, figuring it out as they go. But on the other side, we have the transformer. This one is more like an experienced linguist who is, well, basically already read the entire internet. It uses something called transfer learning, which means it comes to the table with a deep, pre-existing understanding of language. And this distinction? Well, it's the key to everything that comes next. Okay, on to section 2, data and training. Now, before any model can start competing, you have to do the essential behind-the-scenes work. There's this old saying in machine learning, garbage in, garbage out. And it's true. The quality of your data is everything. So, this whole stage was about finding the right data, cleaning up meticulously, and then teaching the models what to look for. The whole foundation of this project was a dataset of 9,000 real-world online comments, and the breakdown was actually pretty balanced. About 58% were non-toxic and 42% were toxic. Now, having a dataset that isn't wildly skewed one way or the other is great, because it helps stop the model from getting lazy and just guessing the most common answer all the time. That's especially important when the thing we're trying to find, the toxic content, is in the minority. And right here, these word clouds really just lay out the challenge in black and white. On the left, you can see the kind of words that pop up all the time in toxic comments. They're aggressive, profane, derogatory, and then on the right, the words from the non-toxic comments are, way more neutral. The job for my models was to learn to tell these 2 different linguistic worlds apart, and not just based on single words, but on the entire context of the conversation. Now, for the traditional LSTM and GRU models, the text needed a serious deep clean. First, I made everything lowercase to keep it uniform. Then, I got rid of all the distracting noise like web links and user mentions. I stripped out special characters, broke sentences down into individual words, that's tokenization, and then removed really common stop words like the and a that don't add much meaning. And finally, I used a lemmatization to get words to their root form. So a word like running just becomes run. This whole pipeline is really designed to strip away the noise so these traditional models can focus on the words that matter most. But here's where things get really, really interesting. For the more advanced transformer model, I skipped that entire cleaning process. I just fed it the raw original text. And you might be asking why. Well, it's because its tokenizer is just far more sophisticated. It's built to understand the nuances of things like punctuation and capitalization. So, by leaving the text in its original state, I actually allowed the transformer to use all of that rich contextual information that the other models would have completely lost. This is a huge clue about its underlying power. Okay, section 3. A clear winner emerges. The prep work is done. The models have been trained. So, now it's time for the main event, the results. It's time to see how our 3 contenders actually performed when they were faced with data they had never seen before. And believe me, a very clear winner stepped into the ring. And here it is. The winning score, 77.11%. This was the final accuracy that the top performing model achieved. It basically represents the percentage of all the comments, both toxic and non-toxic, that the model correctly identified. So, Let's see which model pulled it off. And the undisputed champion was the Transformer model. It wasn't even close. It hit that 77.11% accuracy, beating the others by a pretty wide margin. But it wasn't just about overall accuracy. The Transformer just dominated across the board. It had better precision, which means fewer false alarms. It had much better recall, which means it caught more of the actual toxic content. And it had a significantly higher F1 score. The traditional models, the LSTM and GRU, they were honestly just left in the dust. Now, let's zero in on what I think is the single most important metric here, and that's recall. See, recall measures how many of the actual toxic posts the model successfully identified, and the difference here is just staggering. The LSTM and GRU, they only found about half of the toxic comments. They let the other half slip right through the cracks. In a real-world moderation system, that's just a failing grade. The Transformer, on the other hand, caught 77%. That makes it vastly more effective at doing its one core job. And here is the final knockout punch. The Transformer achieved these much better results while being way more efficient. The traditional models each had around 1.7 million parameters that needed to be tuned. The part of the Transformer I had to train had just under 240,000. That is over 85% smaller. It's really a powerful demonstration of working smarter, not harder. That pre-trained knowledge baked into its architecture allowed it to get a better result with far, far less complexity. All right, last section. What this taught me. So, with a clear winner declared and the competition over, let's talk about the key takeaways. Beyond just the numbers and the scores, what did I actually learn from building and testing all of these models? I've really boiled it down to 4 key technical lessons. First, transfer learning is an absolute game changer. Starting with a pre-trained model gives you an almost unfair ad advantage. Second, the architecture itself matters immensely. The Transformer's self-attention mechanism is just a superior way to understand context. Third, you can't have a one-size-fits-all approach to cleaning data. You have to tailor it to the specific model you're using. And finally, regularization is absolutely essential. It's what stops the model from just memorizing the training data and forces it to learn real patterns it can apply to new stuff. And that really brings me to my final core takeaway from this entire project. The best models, they don't just read words, they understand the context behind them. It's that deeper understanding of nuance, of the relationships between words that truly gives language its meaning. And that, I believe, is the key to building smarter and more helpful AI in the future. Thanks for joining me on this journey.